You'll actually, there's a new faculty member arriving next month who is actually, as it turns out, a brilliant abstract artist and drew all of his own representations of biochemical translation as part of his candidacy lecture. It was quite amazing. So I mean, many Charles Weissman, who directs our infectology department here, has a beautiful collection of Magritte paintings in his home that I was able to enjoy very recently, and it's just very much into the arts. I mean, it's an integral part of the process. I think most people will tell you that scientists are artists, just in a different vein.
I think, the visual arts especially are really, really important in communicating science. And I was very lucky to have someone like Jana Duwasa come to my lab for a couple of years and she actually, her whole postdoc was dedicated towards generating images and movies to help communicate some of the things we're trying to do. So I think that's really important.
Following up on that, a leader at Rockefeller University, which is in Manhattan, as most of you know, told me one time that in his tenure, things have changed drastically, because what had been at one time that there were people who would come to study there, and this maybe is an advertisement for places like Scripps that aren't in New York, but they would come there because they wanted to go to Carnegie Hall and they wanted to go to the museums, and that was part of the attraction for studying, being a postdoc in New York. But he said that was almost gone, because now science had become such hard work that most people who did it didn't do anything else. Do you agree with that?
No, I don't think so. I think that's kind of sad to the extent that that's true. I mean, I think most scientists, enjoy doing, all kinds of different cultural things.
But has being a postdoc, has it become so competitive that you really do have to work? Is it like I take it away from science? Is it like being, first year in a law firm where you're expected to work 20 hours?
I don't think so. I mean, I guess everybody's different, right? But I mean, there are plenty of people in my lab who do all kinds of other stuff. They're not just drones who are there 24 hours a day.
Yeah, that's a difficult problem. I'm going to call on Andrew Acevedo, but you can't ask the same question you wrote down because it's already been asked. So you have to come up with a different question.
If you could change anything that you've done in your career so far, is there anything that you would, or like how you've gotten to where you were, or?
Yeah, maybe that year with the plant system, right? Yeah. No. Actually, well, this was a similar thing. So after I dumped the plant system and I went to Ray Wu's lab, and with the idea that wow, if we could make a synthetic oligonucleotide, we could do all kinds of cool stuff with it, right? So I started working on, there was synthetic organic chemistry. It was horrible. We did not have a critical mass of people, and so it was kind of muddling through, and it took 1.5 years to make one stupid oligo that you can make in 10 minutes these days. And so if I was going to do anything different, it would have been to go and get help from people who knew how to do it sooner. My advisor had to say after 1 year, look, you got to go to this other lab, spend 2 weeks up in Ottawa in Saran Narang's lab, learn how to do it right, come back. And if I'd gone and sought help earlier, I think I would have made more progress a lot more quickly.
Brian?
Mine is equally scientific. I was a first-year graduate student in Berkeley, and we were working on this technology for the Human Genome Project, and we were kind of looking at the scope of the project and how many bases had to be put together in the current approach. And we were kind of nattering around the lab this idea that what if you, on this, instead of dealing with capillaries and having to do separations and all of this electrophoresis garbage, if we could just start like immobilizing, just template molecules all over this glass slide, and we would just put little fluorescent dyes on the individual pieces and build them up, and then one at a time, and then read the whole array, because microarrays are really big. And I thought, oh, nah. And that turned out to be a big bust. That could have been huge, as it turns out.
Thank you.
Others.
We have a question in the back, and I think this will be our last question. We're getting towards the end of the evening.
I was going to ask about the role of persistence, sheer, dogged persistence in the face of any odds, whatever. So I think you referred to that a bit before, but I wondered how strongly you felt that mattered.
So I think the persistence in, following, say, trying to tackle a large problem is great. The thing where there's sort of a fine line is between persistence and stubbornness. and if you're just being stubborn and, like I was in trying to finish doing this chemistry, in our own little lab without getting help, that was really bad. I mean, I was very persistent at doing it, but it wasn't getting me anywhere, right? So I think, you've got to be persistent. I think I've been working on the origin of life now, one way or another, for 20 years. So I think that's pretty persistent. I'm still learning stuff and still enjoying it. So I'm going to keep doing it, maybe for another 20 years.
So Jack, how did life begin?
That'll take a couple of hours to get this. It's going to be once we understand it, it'll be really simple and easy to explain. It's just seems complicated now because we don't understand it. So.
Persistence can also lead to being very dogmatic, and that's something I've tried to avoid. As being trained in biology, you would get, it's drilled into you, the central dogma. DNA makes RNA makes protein, and that's been shattered a long time ago. And it's you have to sometimes be able to zoom out and say, okay, I know everyone's getting all this noise from around me. This is what we're supposed to be focusing on, but maybe there's a different way.
Well, I think that's a very good way to end it, because the idea that persistence is important, but if you overdo it, it can get you into a lot of trouble. And I want to thank all of you who are supporting the Scripps Institution for coming here. I want to thank the Lasker Foundation for all the wonderful work it's done over many years and for sponsoring this. And I thank these two brilliant scientists for their presentations, and thank you all. And good evening.